All right, so I am here today to talk about async iterators. This is a new, relatively new JavaScript feature that has finally landed in Node 10 and some browsers. So now that it's something that we can actually start using in the real world, I kind of wanted to share some examples of practical real world usage scenarios. Chris already introduced me, but I'm Ryan Paul. I'm a technical writer at Stripe, where I work on developer documentation. And all right, so what is an asynchronous iterator? An asynchronous iterator is what happens when you take async functions and you bring it together with iterators. These are two slightly older features. They're also relatively new in the scheme of things, but I think I wanted to avoid getting too deep in the weeds describing these. I think there's probably a fair amount of familiarity right by now, but async functions basically provide some syntactic sugar for making working with promises easier and more straightforward. And iterators allow you to deal with streams of values or sequences of values. Iterators and generators kind of go hand in hand. A generator is a function that creates an iterator. So when you take these two features, these two language features, and you converge them, what you get is a really powerful abstraction for working with streams of values. So in terms of availability, this feature is in V8 6.3, which is in Chrome as of version 63. So all recent versions of Chrome will have this, and Node.js 10, which was released last month, is the first version of Node.js to support this without any flags. Mozilla also recently introduced it in Firefox 55. So this actually will work out of the box in some browsers, but not all. We're not quite sure yet when this is going to land in Safari or Edge. It's in a recent Safari tech preview. I think tech preview 40 was when they introduced it, but it hasn't actually landed in Safari itself in a stable release yet. As for Edge, this one's the real question mark. As far as I know, Microsoft does not include this in the page where they list what their plans are for various features that they're going to implement. So they just really haven't acknowledged what their roadmap is for this yet. But I think that because it's in Node.js 10, we can now comfortably use it on the back end. Node.js 10 is going to be an LTS release, so it's pretty exciting that it managed to land in the LTS. So basically, to create an asynchronous iterator, you write a generator function that effectively yields a promise. So you have a generator function like a function with the little asterisk after the word function, after the keyword function. That's how you create a generator function. And an asynchronous iterator or an asynchronous generator also uses the async keyword. So I'll show you in a little bit what that looks like, but it kind of mixes both of those pieces of syntax. So the other bit of new syntax that we get with this is the for await of loop. So when you have an asynchronous iterator, you can loop over it with a conventional for loop, but you throw in that little await keyword too, and that makes it so that it'll await each new value as it comes in. So it's a slight variation on your normal for loop. And so, as I was saying earlier, this is just a really clean way to represent streams. Okay, so here's an actual code example. What you're looking at here is an asynchronous generator function. At the top there, we've got like a little function that called timer that we're just taking and wrapping a promise around set timeout. And what that does is it makes it so that in an async function, you can await the timer instead of having to use a callback. So then in our asynchronous generator here, what you see is an infinite loop that will just continuously await a 5-second timer, and then every time the timer finishes, it'll yield a new value, and we're just counting up. We're incrementing that counter by 1 each time. So this is a generator that produces an infinite stream of values on a 5-second interval. And so now I'm going to show you what it looks like when you consume this asynchronous generator. So here's where we get to use our for await of syntax. As you can see, it looks just like a for loop, but with that added await keyword. So first we call that counter function, and then we assign the result to that value iter. And when you call that function, when you call an asynchronous generator function, what you get back is an asynchronous iterator. And so now we can loop over that iterator, but use the await keyword. And so now each of those values will come out, but it'll be waiting on that timer. So it's like looping on it, but it's using await on that promise. So the promise has to resolve before you get the value back each time. And so once we've got the value, we're just logging it to the console. So this is similar to using await in an async function. It really flattens things out, and it gives you a cleaner, simpler syntax for dealing with these asynchronous values. But instead of just a single asynchronous value that you're waiting on, like you would normally get with a promise, it's a stream of them, a sequence. It's conceptually a little bit similar to observables, which are like, if anybody's familiar with RxJS. It kind of is thematically similar. Okay, so now let's talk about what's going on underneath all of this new syntactic sugar. Basically, this is all pretty bog standard. So if you're familiar with how iterators work under the hood, or iterator functions, this is all pretty much the same. It's just asynchronous. So an iterator, it's just an object with a next method. And when you call that next method, it returns two properties, value and done. The value is just the value that you're yielding from the generator. So in the case of our example here, their counter. And then done just tells you, it's a Boolean that tells you whether or not you've reached the end of your sequence. So in the case of my infinite while loop, there won't be an end. But if you were looping up to a fixed ceiling, like say you had a for loop that maxed out at 10 and then finished, the last item to be yielded, it would have that done property set to true. Okay, so that's kind of what it looks like under the hood, and literally that is what it looks like. So when you get, like, going back to the previous slide, let's see if I can jump back. When you get that iterator, that iter variable that we're assigning to, if you were to kind of interrogate that and look at what it is on the inside, it's just basically an object with that next function. Okay, so another neat trick is this concept of an asynchronous iteration protocol. So this is also something that should be familiar to people if you've ever worked with iterators. Basically, you want to have a mechanism that you can use to take any old object and make it so that you can loop over it, iterate over it. And you can do this with asynchronous iterators too. And the way that you do this is you use the symbol.async iterator. And it works exactly like symbol iterator. So what a symbol is, this is also slightly new-ish, maybe ES6 feature. A symbol is like a unique descriptor that you can use, like, for example, for a property or a method name. And the reason that you would use a symbol is it's like, instead of using a predefined arbitrary string, like say that you would use a string called async iterator, you can't use that as a thing that you ask people to put on their objects to create this behavior, because you might have a collision if somebody's already using a property with that name. So a symbol just basically gives you a way to create a totally unique property that you can reuse across different objects, like a name for it. So it'll be a little clearer on the next slide when I show you how to actually use it. But any object that has a property or like a method on that object with the name of the symbol is said to conform with the asynchronous iterator protocol. It means that you can use the for await of syntax to loop over it. Okay, so here's an example of defining an object that conforms with the asynchronous iterator protocol. And when you have the brackets around your method name, what that does is it takes the value inside of the brackets and it uses that as effectively your method name. So in this case, our method is named with that symbol.async iterator. And it's just an asynchronous generator function. And you can see here, I've just wrapped that same counter function. But now what's nice about this is that any instance of this class, you can for await of loop over it, and it'll behave like an asynchronous iterator. So I put an example there of what it looks like to consume this. So you can see here in this case, instead of like calling into a method on the instance, we're looping over the instance itself. And we can do that because we've made it conform with this protocol. Okay, so I promised real-world usage examples. So now I'm going to get into some of those here. Some practical use cases that you can start using this for today. So as I mentioned earlier, this is now in Node 10. So if you install Node 10, you can use this out of the box. And one of the other really exciting things that the Node developers did in Node 10 is they made it so that every readable stream conforms with the asynchronous iteration protocol. So the example I showed you earlier where you can take any object and you can make it so that you can loop over it with for await of, they've made it so that anything that descends from a readable stream can be consumed in that way. And so that's just huge swaths of like IO relevant parts of the Node standard library. So for example, you can use it to read files. So in the standard library, in the FS module, we have that create read stream method, which you can use to read a file. So when you invoke that and you pass it the name of your file, you get back a readable stream. It's just basically like a stream with your file information or your file data in it that you can loop over and consume. So normally in the old days, what you would have to do is use events. They have like event emitter, and you would consume this by using the event emitter and then pull out what you want. But now, because it's a readable stream and readable streams conform with the asynchronous iteration protocol, you can use for await of to loop directly over your file stream. And in this example, this is really simple. All we're doing is we're taking each chunk and we're appending it to a string and then printing it out at the console. But you can do all kinds of things with this. Like if you have a very large file that you don't want to read into memory, you can use this to operate on pieces of it at a time, just as you would a stream. I mean, it works just the same way that the normal event emitter path for interacting with this would work. But in this case, it's just a cleaner, more straightforward syntax that works really well with other promises and other things that you can await on. So that's one example of how you can use this today without even having to define your own asynchronous iterators. You can consume things that the standard library gives you that conform with the protocol. So for my next example, this is one where we're going to actually create an iterator. I'm going to show you how to do how to use it for a streaming database query. So in this example, I'm using RethinkDB, which is an open source database for building real-time web applications. RethinkDB has this feature called a change feed. And what it does is it lets you attach to a table or a query and get live updates as the data in your cluster is changing. So when something gets written into the table, it will push the update out to your change feed to your application. And in this example, what I'm going to show you how to do is wrap a change feed cursor with an asynchronous iterator so that it can be consumed in a for await of loop. So to start with, the top line, we're just importing our RethinkDB client library and instantiating it. And then we create this generator function called stream that operates on a cursor. And a cursor is just sort of the abstraction that the database uses for like any kind of stream of data. Like if you have a large query and you're getting streaming results back, or if you have a change feed and you're getting you're watching for changes live, it's kind of this like window into the database content. And in this case, the cursor that the client library provides, the cursor API the client library provides, has this method called next that you can call to get the next item from the change feed or from the cursor. And next, it returns a promise. So you can await on it in an async function, and then you can take that value and do whatever you want with it. So what we're doing here is defining an iterator function that just loops forever and constantly yields each new promise from the cursor. And so an interesting twist here is that this isn't actually an async generator function. It's just a generator function. You notice we don't have the keyword async there. And it's because we don't actually need it in this example. Because the cursor is returning a promise, the cursor.next method returns a promise, we can just yield the promise directly, and it gives you the equivalent of an async generator. If we wanted to, for example, take that value out of the cursor and transform it or inspect it or do something else with it before we yield it, then we would probably want to turn that into a proper async generator, add the async keyword await on the cursor next, and then do whatever we want to do before we yield it. But we can just yield a promise and get an async generator. So in this case, that's what we're doing. Now, what we're going to do next is actually perform our query. And so the query in question here, what that's doing is it's just reaching into the database, and it's using one of the database's built-in system tables that has statistics about the state of the cluster and the activity going on in the database cluster. And we're going to open up a change feed on it. So we're going to get this like stream of statistics about activity in the cluster. And we await the query, and that gives us back our cursor. And then we're going to do our for await of loop, but we're going to take the response from the database, the cursor that we got back from that query, and we're going to wrap it in our stream function. We're going to invoke stream and pass in the cursor. And now we can do the for await of loop over it, and every time the database receives, every time there's an update to that table, we're going to get it pushed to our application. We're going to be able to loop over it. So that's my second example. For my third example, I'm going to show you how to serve an event stream, serve an asynchronous iterator as an event stream. So event streams, for those who are unfamiliar, server-sent events is this web standard that's really great for building real-time applications. You can take an HTTP request and return a stream of messages. And then there's this event source API in the browser that you can use on the client side to consume it. And event source gives you some nice features like it'll automatically reconnect when the connection is dropped, and it even does incremental backoff and all the other kinds of things that you expect when you're building real-time applications. So server-sent events, just this nice set of features that you can use in the browser and on the back end to stream events over HTTP. And it's simpler than WebSockets, but it's only unidirectional. Unlike WebSockets, you only send things down to the client. So for my example, I'm going to show you how to use server-sent events with an asynchronous iterator. And the idea is that you should be able to take any asynchronous iterator, pass it into this function, and just be able to serve it, stream the values as they are yielded down to the client. So to accomplish this, we've got our iterstream function. And what the iterstream function does is it's taking an HTTP request that comes in via Node's built-in standard library HTTP server, and we're going to send the header to specify that it is an event stream. That's the content type header that you use for an event stream. And then it's going to, for await of, loop over the asynchronous iterator that we pass in. And for each value that we get out of it, everything that's yielded by that iterator, we're going to just write a message to the client. And this is the format you can see here, data : it's just the format that server-sent events use that the event source client will parse and read. So then all we have to do is when we get a new request that comes in on our HTTP server, we just take the response and we wrap it in the iterstream function, and we pass in our iterator. And in this case, I'm passing in that counter iterator that I showed you before, the one that loops infinitely and yields that ever-increasing number, right? And so now when the user connects on the client side, this is what the client side looks like, you can pick up all of those events with onMessage. So every time that 5-second timer completes and it yields a new value, it'll trigger our onMessage callback on the client. So now we're sending messages from the server to the front end, and you can pick them up in real time. So here's the thing though. there is a problem with this example. And that problem is what happens when the client disconnects. Because we've got this generator that's running in the background, and we're streaming all of these yielded values to our client. But when the client disconnects, that generator is still there. It's still running. We end up with this generator that continues to run in the background, and we'll end up with effectively a dangling generator every single time someone loads the page, which is obviously not what we want. So, when I was playing with this and I was, understanding how all of this works and figuring out how I could use this in my applications, a naive solution occurred to me first. And that's to use iter.return. So when you have an asynchronous iterator, you have this dot return, the return method that you can call on it that tells it to finish, that tells it to terminate. And so in principle, this will work. When you call return on your asynchronous iterator, it'll finish up and it'll stop looping. But the thing is, the last promise that's still pending when you tell it to terminate will have to finish first. So you're still waiting for that one last promise. And in the case of a timer, it's no big deal because you got your 5-second timer. So you just wait for that 5-second timer to finish up and then you're done. But what about the RethinkDB example, the example where you're sitting there perpetually waiting for the database to send you a new message? You don't know when the next time the database is going to send you a new message. So you have this dangling generator that's going to be sitting there after the user disconnects until at best you get a new message from the database. So basically, what do you do about this? Basically, what you need is a way to cancel the pending promise. So here, real quick, I'm showing you, I kind of glossed over this, but this is an example of just how you would change the iterstream function to wait for when the user disconnects and call return on the iterator. But moving along, yeah, I already kind of explained all of this. I got ahead of my slides. We need a way to cancel the promise. So now I'm going to talk about promise cancellation, how you can take that pending promise and make it so that it's possible to cancel it when the user disconnects. So this gets a little complicated. And I think that the code looks a little bit gnarly at first. So I'm going to step through it slowly, a little bit at a time. So the way that promise cancellation works is you're creating a promise and you're passing that promise into the function, the function that returns your promise. So its promise is all the way down. But the reason that you do this is that you can take and create a promise and then capture the resolve function. So in this case, what we're doing is we're creating a no-op promise. It doesn't actually do anything. It would never on its own naturally resolve. And we're taking the resolver and pulling it out into the parent scope or assigning it to the variable cancel. And the reason we do this is because now we can call cancel and force this promise to resolve. So if we take this promise that we can externally programmatically resolve and we pass it into another function that returns a promise, in that function, we can watch for this one to resolve, and then we know that the user or the consumer has canceled the operation. So let me show you now what that looks like when you're a version of the timer that is actually cancelable. Okay, so here is the timer function. I've highlighted in blue where we've added a new parameter called canceled. And that's the parameter that you use to pass in the promise that you're going to watch for cancellation. And so now we've added another line inside the promise where when the canceled promise resolves, we clear the timeout. We just terminate the timer effectively. All right, so now all that we have to do to get the timer to stop is take that canceled promise that we've passed in and get it to resolve, which we do, let me get back to the previous slide, which we do by invoking it as a function. So you can see here where we're invoking cancel, that will cause the timer to terminate because it's resolving the promise that we've passed in, the canceled promise. Okay, but there is one more piece to this puzzle. Basically, when you have a promise, you don't know how many consumers there are that are waiting for it to finish, that are awaiting it or have .then tacked onto it. And so if you terminate it and all of the downstream consumers don't understand that this is what you've done, it's a little bit antisocial. It's a little unfair. They're not going to know what, these other parts of your code aren't going to know what's going on. So what you need to do in order to make sure that all of the other consumers of the promise know that it's been canceled is you have to get it to throw an exception by calling reject inside of the promise. So we've changed this here now so that when you cancel the timer, it not only terminates the timeout by clearing it, but it also throws an exception that downstream consumers will be able to receive. So any try-catch loop around any consumer that's awaiting this promise will now know that it was canceled. So now let's put all the pieces together. I'm going to show you what the server-sent events example looks like with actual cancellation. We've taken our IterStream function and we've added a thing that watches for the user's connection to close, and then it calls cancel on our promise here. So you can see we added also a parameter so that you can pass in the cancellation function that resolves the cancellation promise. Okay, so now where we consume the IterStream, we have to also create the cancellation promise so that we can pass it in. So here, we're creating the cancellation promise, and then we are assigning the resolver to cancel, and then we are passing cancel into IterStream, and we are passing the canceled promise into the counter function that is our asynchronous generator. And so now, when we call invoke cancel, what's going to happen is that the pending timer will terminate, and that means that when we end of our asynchronous generator, it won't be waiting for that one last promise to finish. And also, we wrapped it with a try catch because it's going to throw. It's going to throw that exception from the reject that we perform inside of the promise. So there is one more piece I actually forgot to put in a slide for, which is how you update counter, but I'll walk you through that real quick. What you would do in counter is just add support for that extra parameter, the canceled promise. And then in counter, you're going to want to make it break that infinite loop when it detects that the promise has resolved. And you actually technically don't need to do that because when the exception is thrown, it'll stop anyway. But we want this to be robust enough that if you are not writing your asynchronous generator properly or whatever, it'll still work as expected. Or if the pieces aren't working, you still want it to terminate cleanly even if it's not throwing the exception. So in your counter function, you would want it to break the loop when it detects that the cancellation event has occurred. Okay, and so yeah, there's the error handling. You're just going to catch it and determine if it was cancellation or if there was some other issue. So you'd want to have whatever other error handling you've got. All right, so for more details about this, I have a blog post on my blog that describes the whole problem and all of the steps I went through to understand how all these pieces fit together. And I've also provided a link there to the asynchronous iterator TC39 proposal. So this is where the original draft is the underlying standard that defines the feature. And it makes for some pretty good documentation. And the issues there, it's because it's in a GitHub repo, the issues there make for some interesting reading. So a lot of the questions that people came up with and we're trying to figure out, does this feature meet all of these use cases and so forth, are all discussed at length there. So that's good reading. And I also left my Twitter handle there for anybody who wants more of the same. I tweet about this stuff. So yeah, that covers it. That is asynchronous iterators. And cancellation stuff, right now you can do it ad hoc as I've done by creating that no-op promise and passing it in. But there is some work on the standards front to create a standards-based mechanism for this. And this has been kind of an ongoing project of some of the people in the standards community for quite some time. There was a previous proposal for cancellation tokens that for various reasons didn't quite achieve consensus backing. But there's a new proposal that's at a very early stage that has I think, a more consensus-based approach that is going to satisfy the needs of that everybody articulated the first time around. So eventually there will be a cleaner standards-based way to perform this cancellation that's uniform instead of having to create these no-op promises and pass them into your asynchronous generators. All right, thank you.